Assalamualaikum and hello everyone. This video is a demonstration video on Lab 1 Activity 2. I Abrar from Group 4 will represent my group to do the simulation in video using the CPU simulator. So let's jump into the first instruction. We need to locate the instruction which is used to store 1 byte of data in a memory location. Use it to store number 65 in address location 20 using direct addressing mode. So let's say at our CPU simulator, the first instruction in the CPU instruction simulation window is store byte 65 and the destination operand is 20. So next instruction is move. We use to move the absolute value of 22 into register R01. So we see here the register R01 indicate the store value of 22. And then next instruction is we use store byte 51 and the destination operand is prefix at R01. This is used to point into the address in the value of register R01. We will see how it works. So this is the example of the indirect addressing mode. When we execute this instruction, now we will see at the data memory. This indicate the 16, 17, 18, 19 and 20, 21 and 22. So in the data memory address 20 and 22, the value is 41 and 33, which is represent the value of 65 and 51 in hexadecimal. So in indirect addressing mode, the value 51 will 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 use the value in register as an address to store the value of 51. So we see here the data memory address is 22, which is we get from the register R01 value. So next instruction is we need to create a loop. So here we move the absolute value 0 into register R01 and then we create a new label, and then the next instruction is add 1 in register R01 and then we compare the value with 5 and then we use the instruction jump not equal to jump the instruction to label R01, which is the label R01 indicate the next instruction address, which is the address of this instruction of add. And then we use HAL to put the program into a rest. Let's see how the program works. We will execute and run the program. So we observe at the status flag negative, and now it's 0. So we need to modify example code 1 so that the program loop is repeated as long as the value of R01 is less than or equal to 3 and test it. So here what we need to do, we change or edit the instruction to compare with the value 3, edit instruction, and then we use the jump if less than or equal so that the instruction will repeat or will looping if the value is less than or equal to 3. Let's edit instruction and we see how it works by execute the instruction or run. So we see here the program will stop when the value exceed the value of 3, which is because we use the jump not we jump if less or equal to. So this is how it works. So next instruction, we need to add a new label, and then the instruction out of value 24, and the destination operand is 0 to put the output from register or memory. And then we use return to subroutine instruction. But the subroutine is no use by itself. We must call it using MSF followed by call. The MSF, which is correspond to mark stack frame, is need to reserve a place for the return address on the program stack. Now we place the instruction of MSF and call before the compare instruction. Instruction L1. Now let's run again and observe here. Okay, now the next instruction is we need to use string, which is we need to enter some text in the text box label value here and click update. Now we reset the program and observe the input output window. Run. Now we have a new program. We need to run this program. Click on the input output button, which will display the simulated console window, and then try to observe the program, how it works. We see the program stack because the program use the instruction push and pop, which is use the top of stack and bottom of stack on program step, the random access memory. We also observe at the status flag because the program use the instruction compare, and we will see the negative flag is on, and also the status flags of 0 is on when the value of compare R01 and R02 is equal. So that's it from us. Thank you.